screen. Okay, so everything fine. And I think that you see also my editor.
Yep.
Cool. So we are waiting a little bit. So waiting, let's say 2 minutes. And we'll see how it goes. I think it's going to be cool today. We're going to write some code, and as usual, when you write some code and you're not only reading, I never know if we will make it till the end. You know, I know what I want to get, the result I want at the end, but I never know if the computer will let me do it.
I got just a general question for you. How'd you even get into like coding in Core Lightning? Why'd you pick Core Lightning? Do you prefer it over LND?
No, you know, I picked Core Lightning. I remember exactly why I picked Core Lightning. It's because I did the seminar from Chain Code Lab about Lightning, and during 5 weeks, you have something to learn, and they give you contents to watch and read through. And so you watch some content from LND, from Core Lightning, from also Eclair, a little bit of LDK. And anyway, I watched a video from 2 videos from Rusty and Lisa, and I go through the documentation. And I found out that they have a plugin system, and just because they had a plugin system, I decided that this was the good place to go. So to me, it was really the fact that if you want to enhance the node, it is built in that you have the possibility to do it without having to change the core code inside it. So the
Very
plugin
cool.
system
Makes sense.
So
now another question. I'm sorry, I know you want to get coding.
Yeah, no, yes, we can ask me whatever you want.
What does Core Lightning need to do to get more market share in the Lightning Network?
Wow, I can't answer this question, because if I did, that would mean that I would be rich, you know. That means I would really understand the markets, how they works, how they don't works, and the only thing that's sure to me is that Bitcoin on any scaling solution, scaling with quotes, double quotes, and with some layers on top of it, are here to stay. So, you know, whatever you pick, you're just picking the right battles in some sense, because it won't dead. So if, let's say, Core Lightning or ND or whatever doesn't make it in 10 years, anything that you do with that is to build something better at the end. You know what I mean?
I do.
But to answer your question, I have no idea. And as we don't know how people are running or not, or how they are doing their business, I'm not sure that we really know what's going on. You know,
makes sense.
With a green light that just come up with a new way of doing Lightning, with LDK that also is doing something that's really different. You have Eclair and Phoenix, which they are really good. It seems to do LSP stuff. You have LND that come with a lot of a good user interface to get started. You know, so I think that you have whatever you need for any kind of developers, users.
Makes sense. The marketing team is just, we're flabbergasted. Like, we're trying to figure out ways to get more people on CLN.
And what do you think, you?
Well, that's a great question. So like the CLN's major selling point is like the plugins and its ability to be, built towards your needs. It's super low level language C. So that is what we're trying to push, but that's not a selling point for a lot of people. Like, they don't understand like the pros of having that flexibility, and so we're trying to figure out ways to better sell. Sell is the wrong word, but better market that functionality.
Yes, I understand. It's a crazy job, I think. It's a crazy job, but yes, there may be lot to learn from the past and from not in the Lightning nor Bitcoin space, but one group that is doing well is the guy that did Dockers. So I don't know if I don't want to promote any things, but it's just that the guys who invented Docker or marketing and did it, when you listen to that guy, they really have a point on the to sorry, I don't find the words, but to be really to make the user experience, the developer and user experience, the more easier they can. I don't know how they did, but it was really something at the heart of their product. So this was something that they're working on always. And now the guys who the founder of Docker is working on the Dagger. It's a CI solution, and the same thing. They are focusing on the developer experience. So I don't know what does that mean, but it seems that when I listened to some interview from that guy, it was just telling that this is something that we had that other didn't. I don't know what does that mean, because I'm new in the tech space, if we can say that like that. But just to share.
Yeah, no, I'm looking at both websites right now, and yeah, I mean, they look very clean and very easily. It portrays what they're selling, what they want to sell. So interesting. I appreciate your input.
So yeah, any question? Maybe if you have some more question about Core Lightning, and what are you working on in the marketing space? Because I know that your Greenlight is new. Maybe you are working on some LSP solution to integrate with it. I don't know.
To be honest with you, I am not too close with the marketing and Core Lightning as of right now. Taking a little bit of a back seat. We're focusing a lot on, or I'm focusing a lot on Jade right now.
Okay. Yes. It's true that there is a lot of things to do.
Mm-hmm. But man, it keeps me up at night. CLN not getting the love that it deserves.
I think that people that love it really love it.
Well, we need to figure out a way to spread the love. You can't have all the fun, Tony.
Yes. So let's go into it and do that last session on Bolt 11 invoices implementation by Core Lightning. If you're okay, Drew, we go.
Let's do it.
Let's do it. So we've already done. So let's go to see that. a bunch of session on Bolt 11 invoices. I didn't think at the beginning that it would take that much session, but anyway, it was a great time to share with you. So we've seen a lot of specific parts during those sessions, and today what I would like to do with you is to do a simple implementation with the tool in Core Lightning, with the tool of Core Lightning, meaning that with we are not going to implement all of the things, but much more taking only the part that we need to make to generate a Bolt 11 invoice, and we are going to use the APIs and the modules already implemented by Core Lightning. And if you want to see more details on what we're seeing today, you can refer to these last 7 videos. And today, what we are going to do is really, I hope this will work. It worked this morning for me, so it should work right now. But it's to write a function, a command, okay, to implement a command that we call my invoice, and we pass it to a required argument, the amount and a description, a string description, and this generates an invoice that we see here at the first field, Bolt 11, and we also output those information that are needed. So why we do that? Because when we write a Bolt 11 invoices, there are some information that we need to pass to the payer of that invoice, and that information is put in the data part of the invoice, and they are called tag field. And in the tag field, there are many that we can put, but as we want something simple to see exactly all the part of the process in Core Lightning to write that command, we are going to keep only the one that are required. So one that is required is the P field, which is the payment hash. So we need for that to generate a pre-image, and the pre-image is the proof that we give to the payer to say that we got paid. So the payer, to verify that, needs the hash, and it does the hash of the pre-image and compare them and see if they match. If they match, everything good. We need also a secret. So this is also hash. So we use a function that compute some hash, some secret. It's for probing. I don't really understand how this prevent probing. I asked Rusty in one of the meetup of the weekly meetup on the Mondays, and I thought that I understand, but now I remember that I did understand, but I forgot. So maybe I didn't understand really well, and we also must to pass a description or the hash of a description. In our case, we are just going to pass the description. So this is the only thing that we need, and we also need a timestamp. So we are going to generate a timestamp, and that's it. But we want to put all of those things together. And if we look here in the board, so let's see again what it is. So we have here, this is the human readable part where we say on what chain we are. LNPCRT is for Beacon reg test. This is the amount, the beg32 separator. Then we have 7 characters, so 1 to 6. 7 characters that are encoded with the beg32 car set, which represents the timestamp. And after we have the tag field that are put there. So we've made 2 videos to see how this is done at the protocol level and at implemented in Core Lightning. So we have those data, and at the end, at the very end, we skip the 6 last one. We are going to talk in a few seconds what it is, but before the 6th one, we have 520 bits of the signature. So the signature is we sign everything that is before, and we sign everything here. Boom, 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 boom. We sign that. So we have that signature, and the last 6 characters are the I don't remember the checksum specified by the beg32 encoding. So this is what should be done, and we are just going to put the piece together, and we are going to do this. That command, we are going to do that command at the same place where invoice command is. We are going to take the code from invoice. At some point, we need to encode everything. So we are going to take that code also and write a function that don't do all the work. So for instance, one of the things that Core Lightning does is adding the routing. And if we look at the man page of the invoice command, we have 6 or 7 or more, I don't remember exactly, options that we can set by Core Lightning, but we want just the minimal one. Okay, so the amount that we have here and the description. And before we are going to start, and normally the file that we are going to modify are those 3 ones: lightning d invoice.c, in the command bolt11, bolt11.c.hash, and I had to modify this one to add a mock function when I did it once, but I did it another time and I did not have to modify it. But let's we'll see if we have to add some mock thing. And to see if it works, we will use the command decode to decode how do we call that? That invoice. So let's see if we are good in time. Okay, so let's see if we can do that in 40 minutes, and if we need a little bit more, we will take more. Blah, blah, blah. So where do we start? Okay, so Lightning. So we go here. So we open a terminal in, I have the Lightning repository clone. I run it for all this live about the invoices with the version 23.11. And let's source contrib startup reg test. So we start with that code. We are going to, so we see Lightning CLI. We see that we are using the CLI that is going to be compiled on that directory. So each time we compiled it on the Lightning D, also each time we compiled it, we will be able to have those changes used. Make clean, because I did some stuff before, and configure. So .configure, we disable Rust because we don't use the plugin written in Rust. With that done, we can do make -c, and let's compile it, so it takes the time needed. And after, I will compile with a key binding, and we won't do that at the terminal. Let's go back to the node, and maybe we go to the file invoice. And the terminal, almost done. So here in the file lightningd/invoice.c, we have the command invoice defined, and we see how it's done. So it is defined as a JSON invoice name, and this is that line autodata that declare to Lightning D that we want this to be an invoice. So when we run at the command line invoice, so Lightning CLI invoice, the function that is executed is a JSON invoice that we have just above, and that function does some stuff. So we are going to look a little bit at that one. Let's go back to the terminal. Now it's done. This should work. So we start to node on reg test, and I hope this works as usual. So Lightning CLI get info, and we want just the ID to see that this is running. So it is running correctly. And now L1, if this is the first time that you watch one of those videos or are here, this is an alias for this. Okay, so with the Lightning directory, which is temporary L1 reg test. Okay, so perfect. And now let's add just a command my invoice to take some those two arguments that we want to take. So we want two arguments. We want them to be required. So let's first do that. So to do that, we go in that one. So this was the first episode where we've seen how to add JSON RPC command to Lightning D, not to Lightning D. And so we take that code. This is what I was telling you. We're going to borrow some code from everywhere during that session to get a pack of everything working. So we are in the invoice.c file, and just below invoice command, we add that code, and I will go through with you. That part is what we declare, how we declare my invoice. So first argument is my dash invoice. So this is the name that we are going to use at the command line. And each time we call that name, we are going to run JSON my invoice function, which is that function that we see above. So maybe we can highlight it. We have that function. Okay, so it takes a bunch of argument there, a command, a buffer. It's not that we don't care, but this is always the same when we define a command. And there are some information. So in the buffer, JSON token and everything, this is where we have the request, if I'm not wrong, and we have the command with some other information. What we define. So we define the first two one are the amount millisat and the car description val. This is what we get from when we pass our parameters at the command line. So this is done by that macro param. So if everything works well, what we are going to do is that we set the value we get to m Satoshi val, and we recuperate Satoshis, and here description val, we recuperate the description in this. P opt, this is not what we want today. We want something that is required. Now, we define here the response that we will send back to the callers, to the Lightning CLI in our case, and this is a JSON stream that we call a response, and we pass it as first argument of the function that start with JSON underscore add. So we add an amount millisat, and we call it amount millisat here, and we pass it an amount msat struct. as this is something that is required, we don't need to check if we have it or not, because we have it. So in the field description, we pass it the value description val. So now this should work, and we are just going to compile that file. So we hope this will work. So it compiles a bunch of stuff after. I think it won't compile that much of this. So I drink a bit of water. And okay, so compilation finished. No problem. We go to the terminal. Now we have to stop the node and to restart the node. So there is something called stop ln, but this stop everything and restart everything. I just want to do that for the node. So we look for the command that started lightning D. So and we get that from the processes like that, and we see at the top for the lightning for the node 1. This is that command that was used. Okay, so we have that. We copy that. And what we want to do is to do L1 CLI. So we want to stop the node. And when it stops correctly, we want to run that command to start it again. So let's see if it works. Normally it should be faster, but anyway. Return. Okay, so what did I what went wrong? Okay, so it seems that it works. So that time the node is stopped, so why it can't start again? It's embarrassing if it doesn't work from the start. Okay, so let me just check if we can do something like that. Lightning D. Because the compilation. No, okay, sorry. Because sometimes it happened to me. Maybe it happened to anybody, but daemon. Okay, so we have to start it in daemon. You know, it's hung there, and we can do nothing. So now in daemon, we get back to the terminal, and we can call lightning CLI my invoice and then, and we off my description, and it seems to work. First things first, we know we've just put some boilerplate to get a function, a command defined that we call my invoice, and we that takes 2 arguments. Okay, not that bad, but if we go back to our note, there are more information that we need to put in it, and we also need to have one argument that puts the Volt 11 invoice encoded. So let's go back here, and now, so I said at the beginning, let's see. So I say, okay, time is good. I said at the beginning that we were going to borrow some code from the JSON, so the invoice command, and somewhere else. Where do we start? Note. So we have msat description. Okay. I see what we need to do. So that command is the command, the JSON invoice that is that function that is executed. And what we do is that in a struct that is called info, we will see that here. Okay, so in something called info, we have the struct B11, and in that struct B11, we put the information that we need, and that B11 struct is what we give to an encode function that will, with those information, encode into the last part that we want. So we can go a little bit down to see what we. So let's see. So we have the shell param, we have the timestamp, we have the payment hash that we've computed a little bit above. We have the description also, so a bunch of stuff that is done here. But let's see at the end what we do. So this is what we don't want to do. In our case, here, what we are doing is that this is done to compute the root int from the command list incoming that is defined in the plugin topology. So in fact, when we run the invoice commands normally, this code should be run, and what return the function, the JSON object that we see at the end is that command. So let's look at that command. So this is something that we've seen before. So it's not that I want to go fast. It's not my goal. It's just that let's see how many things Core Lightning does for us to have a complete implementation of invoice, and we just kept the minimum to get it working. So then the invoice complete is will return something. Let's go back to see exactly that is going to return, because here we are constructing the JSON stream that we return, and if we've seen some invoice produced by Core Lightning, we see the parallel here. These are the fields that we put in it. So payment hatch, expires at, bolt 11, and we have all those things. But this is lost in many. It's I don't shouldn't say lost, but there are many things that are done, and I want something more straight to the point, to see what's the minimum needed to get the invoice. And here, for instance, the invoice create. This is where we store the invoice with the information in the database. Something that we don't do today. So what we do, we just generate the invoice and we lose the pre-image, and so we can give it to some potential payer. But this is not what we care about today. So let's go back at that point to that variable, bolt 11 encode, and what we are doing is really at that point we take all the information about the invoice that is in the info struct, and specifically in the B11 struct that we are going to look at and fill in our my invoice command. And here we pass it the function that is going to sign all the data that we have about the invoice, so the signing function. So in our case, this is something that we want to do at some point with cutting in the code. So we are going also to rewrite bolt 11 underscore encode, taking some of taking all the code and removing what we don't need. So let's go back to my invoice. We are here, and we know that at some point what we want to do is to encode something something here. So we and the something that we are going to encode, we will do that after, but B11 encode, and this is pointer car up. So we have that. I think this is that. Maybe let's go back up. Okay, so this is, yes, this is a pointer to car. Yes, where we have the signature. And we have that. I don't know why we have everything messed here. Okay, so I don't know what's happening with those things. So we have that string. First field that we return, so we call it bot 11, which is going to be B11 encoded. So this is our goal after, is really to get that things like that. But for now, we just call it B11 encode. Yes, sorry, and we set it to LNBCRT. More stuff here, and okay, let's compile that, because I think that we've done almost nothing, but I prefer to be sure that this is working. So this time we can use that that command, but we have to put daemon at the end. This shut down, we get that, and now if we evaluate with the new compiled code, we see that we have the bot 11 with that boilerplate that we are going to replace after. Okay, so we need, let's go back to the node. We need a bunch of information, so mstat description, and those information are some of the things that we have to pass okay, so 1 minute. I want to think about what to do next first, because there are two ways of continuing. Okay, so maybe let's look at bolt11 encode function, because we are passing it the B11 struct. Okay, so let's look at that function. So this is a function that we've looked at. So this is a macro, and that that do some type safe stuff. I tried to understand what was going on here, but I don't understand, so I just skip it. And this is what you get when you work in developer project. There are also already stuff there that that it's better to use, and maybe at some point I will understand exactly what's happening there. But the function that we are is bolt 11 encode this one. Okay, and this function is defined in that file. Okay, so we have it at the end, and this is the functions that do the encoded in beg32 using beg32, and at the end we return that output, which is what we want. And we see here what we are doing. We encode that. So let's that function takes, this is what I wanted to say first. That function take that struct bolt 11. So this is the thing that we are going to build. We are not going to use all the fields because we don't need all of them. So let's jump into the definition of that struct. So here we have the definition, and we have some things to put here. So we have chain params, we have the timestamp, we have the amount msat for the millisatoshis, payment hatch, receiver ID. So this is what we are going to fill. When so let's go back to the first slide, and when this is used, so don't remember. See, yes, I remember. So here in the invoice command, I hope you are with me. So in the invoice, we are generating that new stock, but we are not going to use this because it's a hide thing that that we want to know about. So we want to see what field exactly we are setting on using. So let's look at the new Bolt 11, what's done. So here we allocate some memory for this with the library tal, and then we do some stuff here. And at the end part that we need is MSAT. Okay, so we as argument we take the amount millisat, and we want also to take that. So let's but we don't need all of this, but anyway. So first thing, we go back here in our function my JSON my invoice, and what we are going to do before we encode, we need to prepare the work, and we need the B11 struct. Okay, so we have it now. Let's see how do we set MSAT. So we can set MSAT here, B11 MSAT set like that. And now we don't pass MSAT this one, but the one that we get here from the argument. So MSAT, and to see that we something working, we are going to, instead of using that MSAT Satoshi val directly, we are going to use MSAT. And here we use B11, and we want MSAT. So that we construct the B11 struct to show exactly what we need to put in it. Then we are going to pass it to a function to encode that information that we are going to call my Bolt 11 encode. And while we are doing that, we just print that out in the output of the JSON returned by my invoice. So let's compile that. And okay, so this is what happened when we copy and paste, so no problem. So the first argument here of all the tal function needs, no, this is not this one, but this one is not correct neither. So, okay, so as I don't understand exactly how the management memory is done by tal, I don't know exactly how the things are allocated and also freed. So I just know that the first argument that we put here is from where is allocated the structure that we want to allocate in general, and when as it is done as a tree, when that thing that we pass here get destroyed, freed, everything that we allocated from there get destroyed too. So I think more or less this is what I understand. So maybe as we are doing everything from the command that we get as here as parameter, I think that we can use a command which will be destroyed at some point. And the same thing here for a tile duplicate. So maybe I will make that mistake again after, but it seems that it should work as expected. So go back to the terminal. We stop and restart the node, and we generate. It seems that we see nothing because the number is the same, but the field name changed. This is MSAT. Okay, so with that done, let's go back here, and now maybe we're going to do the same with the description. After the description, we are doing something a little bit of this, and now let's do that at the really end. Sorry, so I change my mind every now and then, or every 2 minutes. But first, we're going to get that right. Okay, so if we are okay with me, we put everything, all of that information is a B11 struct, and we output it in the JSON response of my invoice. So we do that slowly but surely, and this will work. So now the description. So we go back here, and we have something done for the description, something with the timestamp. Maybe we are going to do the chain right now, and after we are going to deal with the hash. Okay. So I told you it was going to be some copy and paste of everything, but at the end, when we have the whole command in, we can just look at what we need to do. So all the info there, we don't need them, so we remove them. 10 param, we need it. Okay, we are going to see what there in 10 param. This one too, but not right now. So let's put it here. Receiver ID no, CLTV neither, expiry neither, and we want the description. So maybe the description first here, and we see again tal Steve. So we need something to allocate from, and we are using command. So please. Someone maybe in the future that see that this is not the correct way, so tell me or find a way to make me. I will correct the transcript after. We have those one. So we have description, time spent, and chain param. Let's see, not this one, and we are going to put those one. So first the description. So the description, we can do that like that. So we just change B11, and we want the description. So this should work correctly. In the note, where do we put the time spent? Timestamp, it's at the end. So we are good here, but the timestamp, I think it's we can look at it in the bolt 11 definition of the struct. So this is a U64. So we need to add a U64. So JSON add. So there's a function for each type we need to put that. So U64, and then response. We call it time stamp, and what we put at the end is B11 timestamp. So we have the timestamp, we have the description that we've added to this, and we are using all the variables that we have defined. So normally it will compile. Okay, we restart, and we see, so now we have the timestamp, or the description is the description that we had before, but we have another way of getting it from the B11 struct. Now let's look at chain-param. So chain-param is defined globally. We can jump here and see where it is defined. So it is defined common duties, but it is set somewhere else, and the chain can go to the chain, which is a struct of chain params. So we jump again, and this is defined in the Bitcoin module. And in that chain, we have some fields that we need for what we are doing. Not that one, but we are going to output it anyway. And we need the Lightning HRP, so human readable part. So if we go to the node, we see here that the Lightning bot starts with ln, and then we put the letters that indicate on which chain that invoice will work. So in that case, it's a Bitcoin reg test. So that information is in Lightning HRP, and this is used at some point when we do the encoding. So let's just output that to see that to see the things. I like to see how things are happening on both of them. Let's go back to see that. I think that if we go back, so chain param, sorry, both of them are strings. Okay, so let's copy them. We go back here. So we are in the code of my invoice, and we need to add some string. And what we are going to do is here, from the chain, and from the chain we want the network name and the Lightning HRP that we are going to put here also. And okay, let's just do that and see if the type are correct, or if not. Okay, seems to work. So we stop and start again, and we see, okay, so we are running on reg test, and we have that information BCRT that is needed for the human readable part of the Lightning invoice. Okay, so we are near from the end of that part, and now we need the payment hash, which is the hash of the pre-match that we give back to the payer as proof of payment, and the payment secret, which is to it's against probing from a malicious node. Payment hash. So now those two things, and after, remember, this is that part that we want to do. It's encoding, and we are going to pass that B11 struct. Let's go back in the invoice function that do a lot of stuff that we don't want today. And the code we are interested in is this one. Okay, so if we have a pre-image and as arguments, it is if we pass some pre-image, we from the command line we pass it. If we don't, we generate random bytes. So this is what we're going to do, because we don't let the user pass a pre-image, and then we calculate the SHA-266 of that pre-image here, and that pre-image we store it in our hash that is the first argument, and this is that hash that we pass in the payment hash here, and we have the invoice secret. This is a function, so we are that deterministic sorry, so from, I don't find the word, sometimes it's hard when you're not English speaker to use the right words that you don't have. But anyway, so from the payment pre-image, it generates a different specific secret and calculate the hash too. So we can go to that function and see what is done, or maybe just to read here. So we derive invoice secret using one-way function from the payment pre-match. So this is done there, and we don't care about how it's done today, but we need that secret, which is SHA-266 things. So we need that, and let's take again payment hash. Where is the secret? I don't see the secret set. The secret is set below, so we are going to look at it below. Anyway, so let's go here. So we generate the random secret with the function random bytes buffer. And we need to one moment. I wanted to copy something, but I didn't. Okay, so we're going to go back and forth because I want it to work and I don't want to mess with the types that we are using. So we need the payment secret here, a hash, and we need also a pre-match. We need to define those three ones that we're going to use. So let's go back into my invoice. We do that here, and the payment secret. Okay, so it is set at that moment. Sorry, I will go down, up and down. But this should gives us the right thing. So okay, so now, okay, so we are at 1 hour, and yes, the times were 1.5 hours for that session. I thought we would have done it in less time, but maybe we need that half hour more. So let's continue. I drink a little bit of water. And Drew, it's okay for you?
Yes, sir. Keep on and running.
Yes. Okay. So we continue. And now we start to see the things taking shape, but we have to change a little bit the name on what we define. Just one thing that that pre-image should be that one payment pre-image. I don't know why it is called pre-image here. I jumped pre-image. Yes, this is pre-image, but I will call it payment pre-image, and I don't know where it is used in the code, but this is that. So random byte payment pre-image, and of the size of okay, I think this is something like that. So we put random byte in the payment pre-image. Okay, let's continue. We use that payment pre-image and size of payment pre-image to set the SHA-266 to 56 of the preimage in that variable. Here we generate the secret and we pass it pointers the preimage, and we have the payment secret here. Okay, so this has some struct to deal with that. And now we want to set payment hash field of B11 and payment secret of B11 to those value. And as we are using, remember, a tal function here, we need to pass it some things from where the allocation is done. So now we have all of this. This should compile, and we're going to add this here. So JSON add one thing that we want, the payment hash. Payment hash, what it is. I don't remember the type. Okay, let's try with SHA-256. So I think this is what, because we don't have something with the payment. We have payment success, but maybe with the SHA-256 response, and we want payment hash, and the last part that we use is that we pass it. So this is B11 payment hash. Okay, so let's try with that, and the next one will be JSON add, and we add a secret. Response, payment secret, and this one is B11 payment secret. So let's compile and see where are the mistakes, because they often struct 266 and expected a pointer. Seems to be, is it okay to do that like that? Okay, so no, terminal, so it compiled, and maybe we get to the point where we have almost all the information we need. Okay, cool. So we have the argument that we passed. We passed to the function. We have generated a preimage, and with that preimage, we've computed the hash that we put in the B11 struct. With that preimage, we also determined a specific secret. We have the remand variable path BCRT, which is going to be used in the human readable part of the invoice, and we have a time stamp. So with that, now we are at the, we can say the third part. So the first part was just to have the JSON invoice command working. Now we have all the information and the required information that we need in the B11 struct that we are going to pass to a function to encode the invoice in beg32. And now the last part is to write that function. So as we did before, we are going to do a copy and paste of the bolt11 encode function, and to pass it the right argument. So now, instead of using the hard-coded LNBCRT with 4 dots, we are going to use the bolt11 encode function. This one, so we pass it the first, here is a tal tal object. So this is for the memory. So we use again command. We don't pass info because we don't have an info. What we have is a B11. That argument we are going to see what it is, but we no longer need it. The signing function to sign the data, and the lightning object. So this is where the lightning state is, and this is passed to HSM sign B11 function to do the signing part, which is done by the module HSM. We won't do that with Bolt 11 encode, but with my Bolt 11. So now let's go to the bolt11.h file. Where it is? So it is at the end. So we're going to copy and paste all of this just to change this to our liking, and we see the end field. We are not using that. It is not required, so we don't use it. We only want the things that are required. We have the context, the tag, we have the B11. This is the signing function with its signature and the arguments that we pass to that function. And this is the function that we are going to call my bolt11 encode, and this is the function that we are going to implement. And we want that macro that we call my bolt11 that call the function my bolt11 encode underscore, and we need to remove the end field in the signature here, and also in the call of that function here. So with that, we are almost okay. Now we go to bolt 11. So this is, we declare the function that we want to use in the invoice.c file. Now in bolt11.c, we need to define that function. That function, we are going, all we are seeing right now, this is part of the real function bolt11 encode, and many things are happening there, and we are going to look at it. We already look at it in other session, but also we are going to do that today. So I did copy paste right now that function. We call it my bolt11 encode. We need to carefully remove that argument that we don't need, and we are not going to use everything that there is inside. Some part we are going to use, but so for now we comment everything, and maybe we want to return something to see that it's working. So let's define our pointed output. So in some way, this is what we will return. Return the output, and to see that this is working, we want the output to be equal to tal string duplicate. So we duplicate from the context that we have an argument. So it's not from the context, is just for the allocation memory, and we want bolt 11. And what do we want from? No, B11 is called one of the arguments. This is what we've built before in my and the JSON my invoice function, and we are passing that argument that struct as the second argument of my bolt11 encode underscore function. And now the thing that we do, we just see if everything is working correctly. So what we return is a description. So it's not the code that we want at the end, but it's just to see that, okay, so we get something from the bolt from B11. this is what we passed. We've defined a new function. That function works correctly and return us something in that line, B11 encode. And now, instead to have in the first field ln BCRT with the dot, we normally are going to have the description passed here, because this is what we return from that function mybot11 underscore, that macro that calls the function with the underscore at the end. We compile, and as we modify some files in another places of the code, we have more stuff to compile, more files. But if it works, it would be great. Okay, everything is working as expected. Terminal, no error. We restart. Okay, sometime takes a little bit of time to. Why? Okay. Okay, and now we call, and we hope that it's not going to crash and give us something. So yes, so this is what we wanted. Okay, so we have to time my description, because in the bolt11 first field, this is what we've just done. We've written that from that macro, that function. So now we can state that, okay, what with the information that we've put in the B11 struct are really passing through that argument to that function. Now let's go back to bolt11.c, and we're going to keep only the part that we are interested in, and we'll try to explain briefly or quickly what's going on here. So if, as I said several times, if you want more details on what's going on here, there are 7 other live sessions that you can take the time to look at, or just jump into the code. But we want today something working with the least amount of code, with the function already and the structure already implemented by Core Lightning, and we see more or less exactly how the part of Core Lightning is implemented. Let's go back to the note, and we look at this. So that string is encoded with the beg32 algorithm and the beg32 card set. So only 32 characters are authorized in that string, and the goal of the string is to transmit information that is highlighted here. This is the goal. Okay, so this is what we do. So at some point, with those information that some are numbers, some are strings, and we need to transform this in that. When the information here is represented with a byte of 8 bits, and beg32 character set contain only 32 characters, so number from 0 to 31. That means that it takes the bytes of bits of 5 bits. So what we do now, that part of the encoding, there are one thing. First thing is to get the information, and this is what we are going. So I will remove the comment here. Longer that. So normally we are just going to uncomment some of the part, compile one time more, and this should work. But now we look at what we do in that encode function. So what we are doing right now, the data, this is an array of U5s, and U5 is just to say that we want number between 0 to 31. So what we do, all along before we do the signature and the last encoding is that we transform all the information that we need to put. So for the and we are going to use the base32 car set. We transform the 8 bits into 5 bits, and when there are not enough bits to fill 5 bits, we pad with zeros. So what we do, all the information, so the timestamp and the payment hash, payment secret, and the description, we put that, we append that to that array that we grow. And at the end, we pass it to a function that does the encoding in base32. So this is the code what we do here. What we return is in that output. We have the amount here. I think we use it, so I will keep it. We don't need the extra field. That part is for the signature. The signature 65 is because the last part, is the recovery ID that we are going to have at the end. And let's go. So now we uncomment the part that fill the data array. So here we have B11 MSAT. Okay, so we can uncomment that, and it is we see where do we could remove exactly, because we've put something in MSAT, but we are going to leave it as it is. But what we are doing here is to check to have the amount in the right form at the end. So if we see here, we use a number which is n for nano. So maybe we can have u, we can have m. So we have some letter which is defined in the we see that we've passed 10,000 millisatoshi, and we don't see 10,000. We see 100 with the n characters. So the code here is for doing that. And what we do, we put that information in the HRP variable, and we see at some point that we've added the Lightning HRP that we see terminal, that we see here for the chain BCRT. So this is done at that moment, and we see the string. So we replace the %s. This one is for the BCRT. So now we have the human readable part, which is done. Let's uncomment that one. Now we want the timestamp, and then we want the target part, and we want the signature. So this comes from the protocol. This one is for the timestamp. So we have the timestamp here, and we put it in the data array that we grow, and we do that with the push varlen u int, and we can look at it quickly. So this is really what we do, and this is done by that variable base32 push bits. So this is something that we did in the previous episode. So if you are interested in knowing why, how something in 8 bits it's transformed into something in array of 5 bits, this is done in another thing, and we put that in the data array. So this is what we do with that function. Here we have the encode s, but we are going to put it after. We continue. And we want that one. Why do we want that one? Because maybe we can just remove that. Just see the part altogether. So now we encode P. So P is the payment hash. We have the payment hash. We passed it in the B11, and we put it in the data array, we append it. If we look at uncode P, what we do is we push field, and we look at push field, what does it does. Okay, fine. We add the bake32 things to the data array, and first we've put the type and the length, because each tagged field is represented with the letter, in that case P, and then the length of the data that we are going to put after, and that data exactly. So we encode the P and push it into the data array. Let's continue. And what do we need? So we need the secret. I want the secret first, and then, so we have the secret here. So let's take the secret. So now we do the same thing for the secret, and the last one, we could uncomment that and see if we have a description hash, we use it. If not, we use the description. And in our case, we are using only the description. So let's put the description. And normally, we've encoded all we wanted to put in that data array. So all those things need to be removed. We remove also some check done by Core Lightning, because we are not writing proper code that is ready to handle everything. So now, here in the data array, we've put in the information in 8 bits into 5 bits array, payment hash, payment secret, description. So I talk a lot, but I want to explain what the code does till now. We so I think that here the only thing that we do is to cast in U8 the thing that was characters, and this is then to be passed here. So at that point we are signing. Okay, so the sign function is a HSM sign that we passed with the argument, and what we want to sign is the data, all that we have so far, the human readable part. We store that in the recoverable signature R sig, and then we do something that I don't know exactly the detail, but with the library sec p256, so we make it compact, and we have the recovery ID here, rec ID, that we put at the end of sig and the rec ID, and we are almost done. And now that we have, okay, last part, now that we have the signature and the recovery ID, so the 520 bits at the end of the signature, no, not the signature, sorry, of the invoice, we pass it in the U5 data array. And once is done, here we just allocate the output, and we do the bake32 encoded with all the things that we've computed right now. So the human readable part, the data, everything. And if this works, this set the Bolt 11 invoice encoded in the output variable, and we end up by returning this. So let's compile, and I hope that I just removed the part that that was okay. Compilation finished, seems to be okay. We go to the terminal, we restart this, and now we run that, and we have finally that invoice. At least we have some characters, everything is working, and we have something that looks like a Bolt 11 invoice with the human readable part, with some with 100 here, the separator, and then we have some other information. What we can do is to try to decode it with the CLI decode. We pass it, and we get something decoded. So this is what I wanted to do with you today. So let's summarize how we did it. Maybe not what we did, but how we did it. Let's go back here. So we've defined and everything using the code written in core lighting. So just copy and paste some of the stuff. We did not invent anything today. So just have something short in some sense. We define a function based on my invoice. We have some parameter, just the amount in the description that we want. Then we allocate the struct B11 that is used by core lightning. We set some of the field of it, so the amount, the description, timestamp, and the chain. We determine a pre-image with random bytes. We take the SHA-256 of that pre-image. We calculate an invoice secret. We store that in the field payment hash and payment secret of B11. And what we want is encoded. And the encoded is done here by the function myBolt11, the macro encode. We pass it B11 struct with the information, HSM sign B11, which is the signer, the function that is used to sign, which take as argument the Lightning directory to be able to pass that to the HSM module. And then we return all that information with the first argument bolt11, which is the first field, which is the B11 encoded. So this is for that part here. And my bolt11 is defined here as a macro. And what we want to look at that macro, so we didn't use everything, only some of the part. And the important part is just that we have some information and we put it from 8 bits to 5 bits into an array called data. Something with the amount to do it correctly. This is pushing the 8 bits to 5 bits into the data array. At some point, we need to sign all that data with the human readable part. We want something, the signature with the recovery ID. So this is what we do here. Then we append that signature with the recovery ID to the data array 8 bits to 5 bits. And finally, here we do the encoded of that array data, and we store that in the output. And we return that output, and that output it is what we use here, B11 encode, unc, that we passed here. Okay, lots of talking. But we are done, Drew.
Tony, this was great. Thank you very much.
Thank you, Drew. And see you next.
Yep, absolutely. We'll think of something cool to make.
Yes. Bye, Drew.
Bye,
Thank
Tony.
you for all.